Hi all. So now we're going to look at our final example for sets, and to do this we're going to be solving the problem of repeats. Now let's first get rid of the solution so that we can actually write it ourselves, but actually let's keep the problem description. So what the repeats function does is that it takes in some list L and essentially should return a sorted list of the elements inside of L which are repeats. So let's look at the test cases like you always should to see how the function works exactly. So repeats of this list, 1, 2, 3, 2, 1. Now as you can see, the number 1 and the number 2 both repeat twice. So the answer that repeats outputs is the list containing 1 and 2, because both of those elements were repeated. Now if we look at the list, the input of the range from 0 to 100. Now, this is a list which contains 0, 1, 2, dot, 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 up to 99. Now, none of those elements are repeats, which means that when we call the repeats function on it, it should return an empty list, because there's nothing that is a repeat. Now, the way that we're going to do this might seem a little bit hard to do with lists. However, if we use sets, then the problem becomes a lot simpler. So what we want to do is basically loop through the list L, and as we loop through it, we keep track of the numbers we've seen so far. Then every time we look at the next number, we see, have we seen it already? And if we have, then we know it's a repeat. And so we add it to some sort of set of repeats. So we're going to have a set which is the seen so far set, and that's going to be empty initially because we haven't seen anything before we loop. Then we're going to have a set of repeats. So like I said, let's loop through the elements. So for lm in L. Now, whenever we're looking at an element, we want to see if we've seen it already. So we'll say if the lm is in seen so far, this means we've seen it already, so add it to repeats. So then we just do repeats.add of lm. Then either way, whether we've seen it or not, we're still going to add it to the list of seen so far. Now, this line should make you think a little bit. We're saying that even if we've seen it already, we're still going to add to the set. Now let's think about what happens in that situation. Because let's say that we're looking at the element 2. Now, 2 is already inside of our set of seen so far. So what happens when I add 2 again? Now remember, going back to our previous discussion about the properties of sets, sets do not contain duplicates, which means that when I add it to the set that already contains the number 2, it'll still only contain the signal number 2. So that's fine. And then once this entire for loop finishes, we should have seen so far is the unique elements in the list L, and repeats contains all the elements that occur multiple times. So now what we basically need to do is return a list containing the repeats. So one way that we can do it is essentially say list repeats is equal to the list of repeats. That'll convert it to a list, and then we just return the sorted of the list of repeats. However, this is a little bit pedantic, and it turns out that instead of doing all of this, what we can do instead is essentially say return sorted of repeats. So we're doing sorted on a set, which should again make you think a little bit because aren't sets unordered? However, what Python does is that it converts repeats to a list, like we did here, and then it just sorts that. So instead of doing all this, we can do this one concise line. So let's see if the code we wrote actually runs. And look, we passed. Hooray. So now, the problem that we've solved is basically taking a list of elements, finding the repeats, and then sorting the repeats and returning them.